So now in this video, we're going to look at a voltage here, primarily, of a 3-terminal adjustable current source. It's the LM334. So what it does is you use a resistor to set how much current is going to flow through the component, basically, and all series components there. So the resistor sets the current if there's other components, as long, it doesn't matter which side either, as long as there's enough voltage to provide the power, the current is going to be the same. It's going to be set by the resistor by this formula here. So it's going to be about 0.064 volts, 64 millivolts, divided by the resistance of the resistor that you use there. And I put a number of examples here. So it does have a 10 milliamp maximum current. So if you have a 6.4 ohm resistor and you set it between the R pin and the V minus, you'll get 10 milliamps of current. And it might just slightly vary, but it's going to be very close. So 10 ohms, again, you take the 64 millivolts divided by 10 and you end up with 6.4 milliamps, and so on. So higher the resistance, the lower the current, but that is the formula there. Not too complicated. And so you set that just with the resistor, as I said, between R and V minus. Looking at the flat side, V plus is on the left, R is in the middle, and V minus is on the right. So over here I have the LM334. There's the flat side, there's V plus, in the middle is R, and at the bottom is V minus. And I have a resistor over there. I spaced it out so it's a little easier to see. Put a couple jumpers there. So once we have a load between those 2 points, we'll have current. So now to take voltage measurements, we're going to use this oscilloscope there. We're primarily interested in the voltage across the current setting resistor. And to measure current, you can see we have an opening here. Sometimes we'll also have an LED in series. But to measure the current, we'll use the multimeter. I have the power supply set to 5 volts right there. That'll be enough to light the LED, and if we were going to light more series LEDs, we would have to use a higher voltage. This is going to provide the same amount of current no matter the supply voltage. You can go up to, I believe it's 40 volts and down to 1 volt, but you need enough voltage to power the load, because that's going to block close drop about 3 volts right there. So we got to stay a bit above 3 volts. But otherwise, the supply voltage doesn't really matter. This will just get hotter the higher the voltage is and the less components in series to absorb some of that power. So now I moved the jumpers that the oscilloscope is clipped to right there to both sides of the resistor. I could go to both sides there. So red is to the R pin, and then blue is to the V minus pin right there. We have the multimeter right there, and I need to turn the power supply on, so we'll do that. So now we got 5 volts right there. We're going to measure current in the milliamps. Sometimes you have to move the red jumper to do that. We do not with this one, only higher current, so we go up to milliamps. And now what we're going to do is complete the circuit. So this is a 10 ohm resistor setting the current, so we expect about 6.4 milliamps of current to flow through here. And just have to go down to V minus, and there you can see it's close right there. And I think it does go up a little bit as it gets warmer. So now I'm going to put an LED in series. So now we added the LED to that. There's one more component that it has to go through, and there you can see that the current is spot on, 6.4. That is what we expected. And down here you can see the oscilloscope. So what that's doing, that's measuring across the resistor. So it sets a voltage across the resistor. Of course you have to complete the circuit for that voltage to build up. Right now it's open. Basically it's like it's not connected to anything. But there you can see that we got, that's 0.1 volts per square. So that's about 0.64 approximately there. And if we bypass the LED, just go to the V minus and where the resistor is, there you can see it's that same voltage. So even though the load changed, we got no load right now, and here we have an LED as a load. Even though the load changed, the voltage across the resistor was the same. Thus the current through it, the load, the multimeter or whatever, it's going to be the same. Now we have a 68 ohm resistor right there. So we have a little more than 6 times the current. Here you can see the LED a little better. I just took the anode, the long lead, put it to the V minus there, short lead the cathode down here. So when the LED is not lit up and I have current flow and I'm measuring there, when the LED is lit up, I'm measuring there and then going to ground. Pretty straightforward. Also, I goofed. I said at 0.64 volts. It's 0.064 volts. That's why it's slightly below 1 right there. But in case, we'll come back and we got the multimeter there. So we will measure the current. And it's going to be about 1 milliamp of current, whether we bypass the LED. As you can see there it shows spot on, 1 milliamp of current there. Or if we come to the LED right there, the current is practically the same. Temperatures kind of adjust things a little bit, but for the most part, it is pretty spot on. It's a current source. And now finally, we're going to do a 100 ohm resistor right there. Same exact test and everything. We'll see that the current, or the voltage I mean, across the resistor is going to be exactly the same, about 0.64, and since it is about 50% more resistance, we're going to have about 2/3 of the total current, approximately. And so it should be about 0.64 milliamps of current. I still have the meter set to milliamps. Might even start beeping soon to let me know it's been on for a long time. But there you can see it's kind of closer to 0.64. If we go through the LED, it shows the same. So of course that's in microamps. So that's actually about 640 microamps. It was actually saying 670. We'll go to microamps. That'll be more accurate now that it's in the microamp range. So let's take a look at what we have there. And so any case, main thing is you can see the voltage is held the same across the resistor there. And it actually is 670 microamp right there. So close to 680, but it's close enough. So in any case, that's the main takeaway. Current source typically has a resistor, and somehow you set a voltage across that resistor, and then the stuff that's in series with it, of course, series components have the same current flowing through them. Make sure you turn off the multimeter when you're done. And we were measuring current there. You definitely want to get it off of measuring current. If you have like a power button, put it on voltage. It's a lot safer for the multimeter to accidentally measure the voltage of something than the current of it. And so that's my tip. I try to mention that every time I make a video where I use a multimeter measuring current. So in any case, that's all there is to it. I really like this component. You just pick a higher value. I think you can go down to 1 microamp. I think it's accurate there. So whatever resistor you need for that. You can keep going higher in resistance to lower the current, but 10 milliamps is the limit. And I can't find my 6.8 ohm resistor if I do have it, so I wasn't able to get about 10 milliamps. I could have got close, but in any case, you should get the point that I was trying to make with this video. So check out one of the other videos that I'm posting. Click like, subscribe, the bell, all that. Check out all the links down below. Donate to Patreon if you can. That would help out a ton. But in any case, thanks for watching. I'll see you on the next video.